Most people believe that direct drive motors are the best choice for electric cars. No gearbox, fewer parts, no mechanical losses. Sounds perfect. But in real-world EVs, direct drive motors are actually far from ideal. In this video, I'll explain why direct drive limits efficiency and performance, and why a dual motor setup with a planetary gearbox is often the smarter engineering choice. Let's start with what direct drive really means. In a direct drive EV, the motor is connected straight to the wheels with no gear reduction. Whatever speed the wheels turn, the motor must turn at that same speed. The problem is that electric motors are not equally efficient at all speeds. Every motor has an efficiency map, and there's a relatively narrow RPM range where it performs best. Now, think about how a car operates. When starting from rest, the wheels rotate very slowly but demand very high torque. At highway speeds, the wheels rotate faster but require much less torque. A direct drive motor is forced to handle both extremes. At low speeds, it must produce huge torque at very low RPM, which means high current, higher copper losses, and excess heat. At higher speeds, the motor may operate outside its optimal efficiency zone again. Because of this, direct drive EVs often require very large motors just to meet launch torque requirements. Larger motors mean more weight, more copper, more iron losses, and higher cost. And despite the simplicity, real-world efficiency actually suffers, especially in city driving where low-speed operation dominates. This is where a planetary gearbox changes everything. A gearbox allows the motor to spin faster while the wheels rotate slower. Electric motors are extremely efficient at higher RPM, and a planetary gearbox lets the motor stay closer to that optimal operating region across a wide range of vehicle speeds. With gear reduction, the motor no longer needs to be oversized. You get the same wheel torque with less current, lower heat generation, and better thermal stability. Planetary gearboxes are compact, quiet, and highly efficient, typically losing only 1 to 3% of power, far less than the losses caused by running a motor outside its efficiency sweet spot. Now let's take this a step further with a dual motor setup. By using two motors connected through a planetary gear system, you can blend torque electronically instead of using traditional gear shifts. One motor can be optimized for low-speed, high-torque driving, while the other can be optimized for cruising and highway speeds. This setup allows extremely smooth transitions with no mechanical gear shifting. It also enables flywheeling, where one motor can disengage electrically while the other operates at peak efficiency. The result is smoother driving, better efficiency, reduced wear, and improved redundancy. Many people argue that adding gears defeats the purpose of electric vehicles, but this argument ignores physics. A small mechanical loss in a gearbox is far less significant than the electrical and thermal losses caused by forcing a motor to operate far from its optimal RPM. In practice, a geared system often delivers better real-world range and performance than a pure direct drive system. So while direct drive looks simple and elegant on paper, it's not always the most efficient or practical solution for electric cars. A dual motor system with a planetary gearbox keeps the motor in its optimal operating range, improves efficiency, enables smooth torque delivery, and results in a better driving experience. Sometimes the best engineering solution isn't the simplest one. It's the one that works with physics, not against it.